So we talked a lot about this upstream, downstream double block thing, so I don't think we need to dwell on that. The sample systems, we didn't hit on this hardly at all. First off, it's required only for routine sample systems. EPA does not define routine in any of their LDAR rules. Seems an oversight. So that's up to you to do. Most people say routine means it's a regularly scheduled sample with a minimum frequency of X. And I've seen that X go anywhere from weekly to annually. But there's no doubt that if you have something it's regularly scheduled, but you only do it once a year, you don't need to waste money on controlling the flushing from that. So these are, if you buy a panel sampler like that, I would guess that's a $5,000, $10,000, $15,000 piece, depending on what the metallurgy and so forth is around it. So it's a lot of money to spend for something you might only do very infrequently. But you need to make up your own definition of routine and add that to your program plan. The other thing that's interesting about this, you're supposed to capture flushing emissions. So by flushing, purging, we're talking about emptying any dead leg line that would not be represent current operations. So you want to get that out first. In the old days, we used to have lines in the rack going out to the tank farm. You'd drop down a half-inch line with a ball valve on it and run it on the ground. Probably take 30 seconds. I'll give it 45 to be sure. Then somebody calls him on the radio and he starts talking, and it's 2 minutes and there's 18 gallons laying on the ground over there slowly evaporating. So that's what they wanted to stop. And that's what it's all about. There are going to be some emissions that are incident to sampling. And the best example they give is if you're taking a liquid sample in a bottle or a can, you're going to get hydrocarbons in the headspace of that, and as the liquid level comes up, you're going to displace those. You don't have to control emissions incident to sampling. You only have to control flushing emissions. So some examples, closed loop, you can get the big fancy panel things, or you can have a homemade one that just goes from the upstream side to the downstream side of a control loop, across a control valve, or across a heat exchanger, discharge back to suction on a pump. Anywhere you got a pressure differential, you can make a closed loop sampler. One thing I think we have concerns in a minute. Closed vent systems, you're going to flush to a control device. And the vast majority of those are gas samples being flushed to the flare system. So usually with a bomb. So you fit a bomb in place, you flush through it to the flare, you turn off, pull everything apart. Okay. Closed purge means you got some kind of a container that you're going to purge to, and you're going to keep it covered at all times when you're not sampling. Then when it starts getting full, you're going to take it somewhere in the plant and rework it, get it back into the process. So you're going to recover it. So this is allowable. We like to recommend, if people are going to do it, to at least invest in this kind of foot-operated kind. So you got a hinged lid and a foot-operated deal, which is good. The guy's got his hands full anyway, so he can use his foot for that. But the good part, as soon as you walk away, take your foot off the pedal, it closes itself. An open bucket being used as flushing control is not compliant closed purge. So some concerns. Bypassing or modifying one of these. One of the things we see is a closed loop system where that's doing a good job of flushing that, but then they'll put 10 feet of tubing on the branch off the closed loop that's not free draining, and so they've got to flush that. So that's making your closed loop non-compliant. Purge containers open. The labeling is more a RECRA thing, not for us. And almost all of these sample systems can be OELs, so be sure you take care of that as well. Sensory inspections, we tell them we're going to anything you can see, hear, or smell. If you've got drips, that's pretty clear indication. Stains or a buildup, a gooey looking stuff like that, it's a little bit hard to tell whether that's a current or a buildup left, residue left from some past leak. So we recommend on that people do the wipe test, grab a red rag or something and wipe it down a little bit and see how fast it redeposits, or if it redeposits. If you stand there for a couple of minutes and don't see anything else, you probably don't have a current, AVO. Not very often. Ice formations can go either way. That could be an internal pressure drop that causes chilling as you vaporize liquid, but it can be through a big leak. So it is worth looking at those. Not very often, but occasionally you can actually see kind of refraction, kind of like the way heat off of asphalt looks in the summertime. You get that kind of shimmery look. And where this really came up with is when we started doing the IR video testing. You get the ones that you can see with that video as you're going around it, looking at it from all directions, trying to get the best image. You often find out, dang, I can see that one with my bare eyes. I don't need a IR for that. But you wouldn't just walking through the plant, so. Yeah, we can finish this at the end of the day, I suppose. We do that? Looks like we got most people back, so we'll do that. Oh, yeah. I'm a wolfer.
I wolfed mine down pretty good. I figured I'd be back in plenty of time, and you guys already got started.
Yeah. Wake up, little Susie. Here we go. Come on. Hey. Oh, I went all the way back. Okay. How am I going to get? Oh, that's the wrong one altogether. Ah. No, there. All right, everybody. We're going to postpone the rest of LDAR 101 till after we break up in the afternoon, and we'll get back into gray areas. We're ready to start with NSPS VVA. And there's something with the drift check language, monitoring DOR components, removing them after 2 consecutive non-leaking, and requirement for 2 months initial valve monitoring. Come on. Oh. Move that gadget over. There we go. So in the drift check language in VVA, which was copied mainly from the consent decrees, that's the first place drift assessments showed up, We've got record the instrument reading on each scale, the date and the results. Calculate the average algebraic difference between the 3-meter readings and the most recent calibration value. Divide this algebraic difference by the initial calibration value, multiply by 100 to compress the calibration drift as a percentage. Does that sound familiar to anybody? Your quarterly precision calculations, maybe? That's what we do, although don't compare it to the most recent calibration. Walt Williamson, who was then a BP, brought this up to ISA probably in 2008. And Karen Brackley, I can't remember her new married name, initially said, no, there's nothing like that in there. And then she came back after lunch and said, whoops, looks like we had a cut and paste error of some kind on the final thing. We'll get this clarified. Hasn't been yet. So what you have to do then is, again, it's one of these, what's your risk tolerance? A lot of people are doing their drifts in triplicate so that they can do an algebraic average and compare it to their morning number. Does that make any sense? Not really. It certainly doesn't improve it, because it's hard enough to keep guys from trying to do things to make their instrument pass before they get a reading on it. You know, everybody wants to come in from the field and clean out their filter, right? You've been doing it all day long on a fairly regular basis, I hope. But the first thing that comes into your mind as you quit monitoring and you know you're going in to do your drift assessment is clean my filter, okay? What's the temptation going to be if you know you have 3 chances on the drift assessment and you fail your first one by 10.5%? You're going to start doing something to try to get it to pass on the next 2 runs so that overall you don't have to go back and redo any monitoring, right? Whereas if you're going to do just a single, by the time you've got that reading, it's a little harder. You feel like you're cheating more if you were to just say, oh, that doesn't count, and then do something and then record a passing record. So I think having the triplicate actually causes you to do more to kind of falsify the passing. The other thing is they tried to give you a break. In the consent decrees, it says if your reading drops by more than 10% from your morning reading, then you have to go out and remonitor everything over 100, but less than 500, to see whether they would have really been a leak if your analyzer had held its calibration better. That's a lot. It's not, it doesn't make much sense that if you were 12% low on your calibration drift, that you should have to check everything from 80% low up. And so to take care of that injustice, they wrote the VBA rule so that you go and check the same percentage below the leak definition as your drift was low. If you're 15% low, you checked everything that was low within the 15% of the leak definition, okay? And so forth. But it's a complicated enough little calculation that it offers more opportunity for you to maybe get the wrong number and go remonitor the wrong things, or possibly not remonitor anything when you should have had 1 or 2 you needed to go recheck. All right, so the bottom line, nothing has been changed in the rule or clarified or corrected, so you've got to decide how you want to do it. Either go ahead with extra work that's counterproductive, or live with a single and try to justify it based on the verbal we had in the ISA. Removing components from DOR, we talked about this a little bit a while ago. They have the thing in there. I just have it as 2 consecutive non-leak readings, but it reads 2 consecutive monthlies. There was a rumor for a while that if you use this to pull a component off a delay of repair, that you couldn't put it on delay of repair again if it started leaking and you weren't able to repair it online, which might mean you'd have to isolate part of a unit or shut down part of a unit, derate it, do something really extreme. There is no language that indicates that. I don't know where that interpretation came, but I've heard a number of people say, well, we're not going to use it because of that. This is one. Some people say, well, my database won't let me retire a leak unless I have a repair type and a passing reading. And what do I put as a repair type? One I like to recommend is delayed effect of previous repair attempts. We didn't do anything right now. We did something a while ago, and it finally got there. It's weathered off everything that is squeezed out or whatever not.
Can you describe that scenario, just like from detection of the leak, or how that progresses? I just want very clear.
How something might stop leaking on its own?
Oh, I understand
Oh, okay.
that.
Okay, yeah.
I'm just, maybe if I can throw it out there, you find a leak.
Mm-hmm.
There's a repair attempt, or there has to be a repair attempt.
At least 2,
Right.
I would say.
It's still leaking, and you put it on DOR. Then you follow through with your next monthly monitoring. No leak, no other repair attempts, nothing. The next repair, or the next month, no leak under the leak definition.
Mm-hmm.
So at that point, by that definition up there, you can remove it from DOR.
Correct.
I just get a little squirrely about it.
It usually takes longer than I would say. The typical thing was, let's say you found it. It was 5,000 when you first got it. You got it down to 900, and you put it on delay of repair because you couldn't get it below 500. First month out, it was 750. Second month out, maybe it went up to 1,100. Next month out, you get 450. Next month after that, it's 300. So now we've got 2 successive non-leaks, and you can pull it.
How do you feel about doing that?
There's at least 1, I think 2, consent decrees that explicitly bless it to be done. And the one I know of for sure is Murphy Oil. You want to look that one up? They had one plant up in Superior, Wisconsin, that was rather small, and they did their run, all the units in the plant stayed up the entire run, then they shut the whole plant down and did a whole plant turnaround. So they would go from 0 delay of repair, and it would just keep building through the run. So EPA looked at the number, which at the time they came in was like 186 or something like that for a plant with 12,000 components. And they said, oh, this is far too high. You can't be doing this. And they were going to put a cap on them and all this stuff. And so as we went through the negotiations and so forth, they said, oh, they accepted the cap and all and whatnot, but they came out, EPA came out with the concept of an optical win. An optical win is something that makes it look like they have greatly increased the stringency or effectiveness of the requirements being put on you, but for which there's very little impact on you to complete it. And one of those that was accepted into this as an optical win was that they would start taking things off the delay of repair list after 2 consecutive non-leaking deals. So they were able to show that, go talk to their bosses, yeah, we came in, these guys had hundreds on delay of repair, and we got it down to 40. after the consent decree was written. Knocked it right down there. Yeah. So, but yes, it's in there, and it says you may use this. So it may not be in your consent decree, but the fact that it's in one, and one that may be a little later and more stringent in other ways than yours, might make you feel confident enough to use it. There's certainly nothing that explicitly forbids you to do it. And they're usually pretty careful about saying that they're not countervening any of the rule requirements. Certainly anything in an underlying rule that's more stringent than what the consent decree requires will always apply and take precedence. We were talking about extraordinary repair attempts this morning, and how the consent decrees, the very early ones said you had up to 30 days to do your first drill and tap and 45 days to do your second before putting it on DOR. And about 3 consent decrees in, they added the language, as long as they're not required to have DOR at a shorter time frame by another rule. So they were thinking consent decree leaks over 500, but less than 10,000 that wouldn't trigger the 15-day rule for BV or triple G. They could do that. But if it goes over 10,000 and you have a hard 15-day or delay of repair, then you have to go ahead and provisionally put it on delay of repair pending completion of the extraordinary repair attempts. And then if one of those fixes it, you can pull it off. And or if that, you were talking specifically HRVOC, but have the same thing in the consent decree write-ups as well. The other one besides that delayed effect of previous repair attempts is AOG. You know, we always like these little acronyms in our pick lists. Y'all know what AOG is? Act of God. So that one's kind of fun, but I don't know whether that sense of humor would carry through very well. So monitoring frequency for DOR, we talked about this a little this morning, as to whether you explicitly have to go to monthly while a component is on DOR. The consent decrees say at the normal monitoring frequency, but they also say that nothing in the consent decree exempts you from a more stringent requirement. And it sounds like where this says, when a leak is detected, the valve shall be monitored monthly until it's not detected for 2 successive monitoring events. So 2 successive months. So we got monthly and months saying that seems to be their expectation. Yeah, Bo.
So Buzz, you're saying that even if it's out of service, you think that there should be a monitoring event on components that are on delay repair?
I would almost say that's the most important ones to have on there because of how frequently we're seeing the isolation fail. Now, if you really got it blinded off and you're confident of the purge nature and that there's nothing going to be able to get back in there, maybe. But if you got it anywhere that there's just a block valve as your isolation point, I would definitely want to be monitoring those.
Because we typically put them on delay repair and put them out of service at the same time.
Uh-huh.
And that removes them from the schedule.
It does. It does. And, you know, I think that's defensible. But if you got them, again, if they're hard isolated with blinds, if they're behind block valves, I don't know whether you have a leg to stand on to say it's out of service. And if you tested it and it was, I would still think that monitoring it would be a good check to see that it's holding isolation. You could probably get by without it, but I think it would be a good idea to do it. Initial monthly valve monitoring. Well, we were talking earlier on another one of these things. We mentioned this Detroit letter that came out to the effect that, and that needs to be struck out now because I think it has been added. Is that right, Chris? That ADI letter on ADI on the Detroit initial monitoring? I think it has been added, but I'm not positive of that. Now we got HAN. This is one of the cleaner of our rules, but there's still a few little puzzling things in it. It's the one and only regulation that has a repair threshold that's different from the leak definition. And they have that only for pumps. Okay? Got a valve monitoring frequency determined by percent leaks as a rolling average the last 2 monitoring periods. We got monitoring requirements for disturbed connectors. And it's got instrumentation systems, which the only surprising thing about that is why we don't have it in all the other rules. But it is a little bit quirky and unusual. So the pump leak thing, the leak definition is 1,000 unless you're a polymerizing monomer or food grade. But you only have to repair at 2,000. I'd ask why the difference, but it's already there, so you guys can read. They had this quality improvement thing. This was actually EPA's first and very feeble attempt at low leak technology. Yes, sir. Yeah.
What determines that? Is that you saying that you're a food grade manufacturer, therefore your pump is food grade? Or is that?
I would say if your product is regulated by FDA. So, okay, for the industry. But you might have some non-food grade pumps within a food processing facility, I guess. I don't know, to tell you the truth. I doubt seriously anybody is going to challenge you if you designate it that way.
That's the first time I've seen that somewhere. I don't recall seeing it in the common for our products. Or a lot of our food when they manufacture food grade materials.
Yeah. Might be worthwhile. The pump repairs are not cheap. If you get a few more thousand ppm tolerance on it, then might as well. So this quality improvement program was set up so that if you had either 10% or 3 pumps total leaking, and that varies which is controlling depending how big the, your facility is. Yeah, Mike.
Yes, sir. Back step just a second.
Okay.
Is that only the pumps or is it the whole stream on the food grade? Food grade is exempt,
Oh, it's only the pumps,
only the pumps.
as far as I know. I haven't seen anything on connectors or valves.
Connectors, valve, the rest of the stream is still applicable.
Yeah.
Thank you.
And this one, there was a valve QIP as well. It was when if you went over 3% or over 2%, you had the choice between going to monthly monitoring or entering a valve QIP. And by quality improvement program, what they meant was you would go out, see what you could find in the marketplace. It was maybe a better mousetrap, a better seal, a better packing, a better whatever. And you would try some of them out over a period, and you would pick the ones that worked best in your facility, and you would install them until you were able to get your leak rate under 2%. Okay? And so for valves, you had the option to just go monthly. So almost everybody said, yeah, I'll monitor monthly and keep my investigation to myself rather than sharing it all with EPA. On valves, it's triggered by what, 2% or more of your valve. On pumps, it's 10% or a total of 3, which changes at, I guess, 30 pumps. Those two become equivalent, 3 and 10%. But 3 leaking on a unit with 40 pumps would put it in the QIP. Would not require QIP. What it said, the greater of, okay. The greater of. That's what gets you there. So this one hit 10% with 20 pumps, had 2 of them would hit 10%, but wouldn't have to do the QIP till they hit 3. But then from 30 on up, it's going to be the percent that brings you in. All right. So that's what this stepwise was about. It looks like they were doing you some kind of favor to allow you to go to 2,000 before you repair. But in the end, what they were doing was helping you get into your QIP faster, which would force you to upgrade pump seals and so forth. Then we got the performance-based monitoring. So it is over 2%. You go monthly monitoring or QIP, 1 to 2% quarterly, 0.5 to 1 semi-annual, and under 0.5 annual. They proposed in the uniform standards an under 0.25 that would let you go to biannual or biennial, whichever it is, it's every 2 years. So they're still looking at maybe extending it further. EPA likes this approach much better than the just staying under 2% for longer and longer, as in the NSPS skip period. All of these percents are based on a rolling average of your last 2 monitoring events. Okay? That means it could be your last 2 months if you're on monthly monitoring. It could be a month and a quarter. It could be last 2 quarters, a quarter and a semi, last 2 semis, semi and an annual and a monthly if you triggered back. There's all kinds of weird combinations that you could get, and that's a pretty hard one for the database to do and get right. And we don't run it. We started out with most of the consent decrees early were in petroleum, so we don't have a lot of HON units, but where we did go into those and hand calculated the rolling averages, we found several mistakes in monitoring frequency almost every time we got into that kind of detailed check. So this is something that they were trying to give you a little break. Because the idea was to be, any one time you go out, you might hit a spike. Maybe you've had a little blip in the power, some extreme thermal conditions or whatever that's caused this. And we don't want a one-time event to force you into more frequent monitoring. So by going to the rolling average, if you were lower before and lower after, then your rolling 2 event would round that out and keep you at your steady, correct monitoring thing. But in effect, it makes it so difficult that you can often get on the wrong monitoring frequency. 8 years on connectors, yeah. Yeah, we are. And you can get out to 8 years on connector monitoring. Yeah. Yeah, I think it's the same. I think it's a rolling average of the most recent 2. There's some consent decrees that have a low leak technology requirement for 2 out of the last 3. I don't recall anything, but I haven't looked at it in a while, so I wouldn't guarantee it. I always go check when I get one of these. It's a little bit outside of what I see daily. This one, it goes to connectors, and it's got a requirement in here that says each connector that's been opened or has otherwise had the seal broken shall be monitored for leaks when it's reconnected or within the first 3 months after being returned to OHAP service. That would be, if you knew it happened, it would be easy to get somebody out there in 3 months to check it. The problem is, how are you going to find out about these? Somebody rolls a blind, open, close, and back again. That's 2 disturbances to that flange. That's not going to go on MLC. It may be somewhere in an operator's log, and you could try keyword searches if that's an electronic thing. If it's a hard copy one, forget it. You can go in there. But it's just darn hard to find it. But there is a way to get around the whole thing. So, it says here in the area that talks about how you calculate your connector leak percent, that an alternative to the requirements in paragraph C1I, which is one we were just looking at, an owner or operator may choose not to monitor connectors that have been opened or otherwise had the seal broken. In this case, the owner or operator may not count non-repairable connectors for the purposes of I2 of this section. So the way it's got it, you've got leaks from previous monitoring periods that are still leaking as you go out now. And the way the connector calculation for each period is set up, you can subtract off those non-repairables from a previous monitoring event from the ones you find, from the total. That would include the ones you find now and those previous ones. So that will give you a lower percent leak and potentially less frequent monitoring. But if you choose to take credit for the non-repairables, then you have to do the 90-day, 3-month follow-up on the disturbed ones. In most cases, I think I would prefer to monitor a tad bit more frequent and not have to worry about how many of these things have been opened and I don't know about it. Of course, it's one of those that's going to be really hard for auditors. If it's hard for you to find out about it, it's going to be even harder for auditors. And there's many things like that. Many things like that. Instrumentation systems. We briefly talked, well, I guess that was during the 101 we did with the smaller group. These are instrumentation, tubing, valves up to a 1/2-inch, connectors up to 3/4. They're treated just like the AVO stuff, like heavy liquids. If you see, hear, or smell signs of leakage, then you go do something with them. Boy, it would be nice to have that in other rules. I would guess maybe somewhere between 5 and 10% of your total valves might fall into this category. And be able to pop that out of the mix would be really nice. There's no particular reason. I mean, Hahn is trying to control HAP emissions, which seems a whole lot more serious than the VOC. So if this was a thing that was reasonable under Hahn, why isn't it reasonable under all these other rules? The answer is they hadn't thought of it early on, and they're not picking it up now. In the proposed uniform standards, this was one thing that was kind of a benefit that they had the potential to make available to all rules. But that was going to be a menu thing. They were going to have to go back and revise each original rule and say, you will now comply with VV by complying with this, and this paragraphs out of the uniform standards. So they still had the option to include or not include this thing, and we don't know, never will know, I don't think, whether we would have gotten any benefit out of it, but that's that. Okay, refinery MACT, we're almost done. Gray areaing. Compliance date for a new unit and modified Hahn. We talked about a lot of compliance stuff on VV. The refinery MACT, subpart CC, is actually even more. You go to the section that has the equipment leaks, LDAR stuff, section 648, and there's nothing about compliance state. You have to, and this is kind of like HAN, it's got tanks, loading racks, miscellaneous process vents, a lot of other things in it besides the equipment leaks. You have to go back to the general introduction to it, and that says that overall, refinery MAC compliance calls for compliance by startup. We thought that 30-day letter was putting our feet to the fire. Now what? We got to be in compliance with LDAR by startup? I had to start getting creative then. If you go to the equipment leak section, there's some applicability and definitions, and then it gives you the options of either complying with the requirements of VV, no, it's not VVA. It should have been a modified HAN. I don't know how that got in there twice. That's your two choices. Go to VV or a modified version of HAN. Both of those allow 180 days compliance time. So if you're complying with one of those referenced rules, then you're complying with MACT. So that's the only way to rationalize. There literally is no way on equipment leaks to be in compliance at startup, because in compliance means you've monitored and you're repairing the leaks you found and you're reporting and so forth. So you can't have done that and have it ready at startup. I mean, it just can't be done. So that's the only thing that makes any sense, but it requires a little creativity to get there. The modified HAN, that's the option to VV. It's really just like HAN, except there's no connector monitoring required. And on those percent valve performance-based monitoring, they're all bumped by 1%. So instead of over 2% as a QIP or monthly, it's over 3%. And if you're willing to do one of several partial connector monitoring options, you can add another % and have it, anything over 4 goes to monthly or QIP, and then coming on down, everything else moves up by 2%. It was not used very much in the refining industry because they already had triple G causing them to have VV-based programs. So there didn't seem to be a good reason to differentiate and go off on modified HAN for this. I can really only think of 1 or 2 sites that ever chose to do this. Yes, sir?
Let me go back once for a couple slides. So I got one question. We had a new unit that was built applicable to GGGA requirements, and also had apps applicable to subpart CC.
Okay.
Now, in that unit, we use the VV option to comply with the CC rules. Now, for some reason, we went to VVA or VVA instead of VV. Is there any issues with that?
I don't think so.
Just lower the definitions, is that right?
You know, it's got in its applicability language, it's got that same exclusion sentence that we had problem with GGGA, or it's in VV. It says if you're complying with triple G, triple GA, KKK, VBA, then you're excluded from this rule.
Yeah,
So.
Our basic approach has been if it's GGG, we keep it for VV. If it's GGGA, we keep it for VBA.
I think that's fine. I don't see any issues with that. Briefly mentioned while we were talking about the OEL deviation thing, this refinery sector rule, it's mostly not LDAR, but it does have that OEL issue in it. And it's also got more requirements for monitoring atmospheric PRDs, which is kind of an LDAR deal, but it's on the edges of it. Not much there. All of the deadlines for comments is already over. That went into like November or so, I think. And so there's not much need to dwell on it now. They haven't come back and finalized it. So maybe by next year we'll have something on that to say what actually happened there. And we started, these are some of the most recently added, some gray areas that cut across all the rules. And the first one of those we're going to put on here, that isolation of a leaking component, and stop the clock. To stop the clock. Okay. How many of you in here have heard of or are practicing stopping the clock on a 15-day repair cycle? Any hands? One? Yeah. It's been part and parcel of LDAR since day one. And the thought process is the reason for putting a deadline on your repair is that the longer it leaks, longer it remains leaking, the lower the overall repair effectiveness of the program is. And in fact, we've got, there's a table that comes out of there that says if they made you fix it within 1 day, that your overall program would be about 99.9% effective, and it would reduce emissions by 99.9%. 5 days, 99.3, 15 days, 97.9, and 30 days, 95.9. So they were looking at that, and they weighed those various options, thinking about all the different equipment types and how involved the repair is, and specialized personnel you have to get out to do some of them and so forth, and decided that in terms of getting a reasonably high emission reduction without creating an unworkable time period, that 15 was the way to go. So it's clear from all of this that the 15 was based on how long that we would accept the leak enduring, okay? So if you haven't repaired the leak, but you've stopped it from leaking by isolating it, you shouldn't have to count the days in which it's not leaking, because the 15 days were meant to minimize leakage, right? If we've got it effectively isolated, we don't have to count the days when it's not leaking, so we have effectively stopped the clock on the repair allowance. And this is kind of important because they also changed the definition of repair. Say it means whatever action you take to minimize or eliminate the leak, and monitoring with a reading below the leak definition. So if you isolated it, put it on DOR, that's the easiest way to track it as isolated, and the clock ran out, then when you put it back into service, you'd be immediately out of compliance, because the clock has ended and you haven't completed repair, even though you've done the physical action, but you haven't had the chance to monitor it for at least seconds. You're probably not going to be standing right there as they put it in and open the upstream valve and stick the probe down there. Maybe you could claim you sneaked into compliance that way. But if this example says we detected the leak on day 0, isolated it on day 8 after several failed repair attempts. So the clock is stopped. It has 7 days left in the bank. Component is returned to service on day 30. Then you still have 30 days to complete the repair and/or repair verification monitoring. So it's a concept, it's been widely used. It's not mentioned anywhere in any LDAR reg. But again, like a number of these things, I know this has been widely used, and I've never heard of anyone getting an NOV for doing this. So again, risk tolerance.
Well, it seems if you have a component that's, maybe I lost something here, but you got a leaking component. You can't, you tried to fix it, 15 days haven't run out. You can't fix it. So you isolate it from service, and place it on delay repair.
Mm-hmm. There's actually two ways to track it, and that's what this is. You can place it on delay of repair, or you can mark it temporarily out of service. And I much prefer and recommend the delay of repair. That's reason number 2 in the list of 4 things that would allow you to put it on delay of repair. And there's a lot more. You've got a sheet, a form you fill out, people sign it, there's recognition of what's going on. Whereas TOS is more, tell your database administrator, hey, click this thing over as temporarily out of service. Or even sometimes the technicians can do it in their handheld, and it comes in that way when you load it back up. So you just don't have as fine a set of documentation to support what you've done through the TOS as through the DOR, I think. Although, again, there's nothing anywhere that says that you can do this, much less saying how you should document it. No, this is one that we started another that's not specific to any rule. This is just general. Yeah. It could apply to any rule that has a repair deadline. So if you don't let the entire repair deadline tick away without isolating it and stopping it from leaking, then you have some of that. The concept still applies under any rule that has a repair deadline.
You could try that even with your first attempt. 5 days.
You could not conduct the first attempt and isolate it within 5 days? Yeah, you could. Yeah. Yeah.
It's isolated until it's gone.
Mm-hmm.
So it just goes on DOR, and then when it comes back in, we treat it like a normal DOR. Don't you have 15 days to recheck it? After a DOR is repaired?
How does that language read?
I got 60 minutes.
Look that up.
It's like immediately after repair.
Yeah, as soon as practicable after repair or something like that, I think is what the language is. But it's not a specific time. It doesn't really give you a lot of grace. So, yeah, you repair it while you're down, and you can't get in for the first day or two, and yeah, that's where this really is kind of nice. But on your pump comment over here, even though replacing the seal is usually the only practical long-term thing you can do, there are a couple of things that can qualify as a first attempt at repair. Steaming the pump seal, turning it off and cycling it back on and off will sometimes allow the mechanical seal faces to mate a little bit better. And one of the fan favorites is washing down the whole seal area with a non-VOC cleaner, like one of these citrus-based cleaners. Yep, getting insulation out of the way that may hold residue under it. All of those, the way the description of first attempt reads is it's, actions that may be able to reduce the emission rate as reflected by method 21 readings. And so these things, people take them to heart, and sometimes it works out real good, sometimes not so good. I had one guy who was in one of these classes, and we went over that stuff there. And I got a call from him about, 6, 7, 8 months after the course. And he's, man, I wanted to call up and thank you about that tip on first attempts for pumps. I said, really? That's good. Well, you had good luck with it? He said, yeah, we got that spray soap thing, and we've been repairing half of our pump leaks without changing the seal out. And most of them only last a month or two before they're leaking again, but he said, I got one that's been running 7 months now, and it hasn't re-leaked. All we were reading was the residue. Once we got that all out of there, it hasn't leaked a bit. But he said, what I'm not sure about is I put that one on delay of repair because I was going to upgrade the seal system, and now I don't need to do that, but how do I trace back and change that? Yep. Well, I'm glad it's working good for you, but I'm afraid you misapplied it a little bit. Once you take that DOR, you're committing to upgrade your seal system. If you haven't done so, you're in violation of your DOR. So, say again? Yes, indeed. All right. So that's to stop the clock. Mm-hmm.
So if you put a component on temporary out of service that you want,
Mm-hmm.
it comes back in service, and let's say it fails.
Yep.
Automatically.
Well, it depends a little on what you did. The one that seems absolutely airtight is like it was a valve that was leaking and you replaced the valve, okay? Then it's clear that you just didn't pre-adjust the packing on the new valve correctly. You ought to be able to repair it easily without it going on DOR again. But that's a new leak. So you can retire the old leak and create this one a new leak. A lot of people will actually give it a new tag number to make it more readily understandable that, yeah, we retired from service, tag number 58645, and we put in tag number 68733. And where service starts from now at this point. Now, getting that accepted in some databases is a little tough because they want to see a repair attempt and a reading. And they usually have replacement as one of your pick lists for repair attempts, so you can do that, but it's hard to get around that reading in some of them. So I've seen some people that put in an artificial number like -1 that you would normally never record out in the field, and that allows them to retire it because it's under the leak definition, and it's something they'll always see right away as to what they've done. Don't know whether that's the best way to do it or not. You step down from that, let's say it was a valve leak, and you repacked it. It's not quite as clean as a complete new component, but if you did a reasonable job inspecting it, you had a reasonable expectation that since the packing is the primary seal, presuming that your place where you found it leaking was around the stem or the packing, you would say that you put in basically a new seal. And, passing the red face test, not quite as easy on that one as a whole new valve assembly, but, it's still not so bad. I would tend to call that a new leak as well. If you've done anything less than that, then you're not going to be able to do it at all. Pumps you're almost never going to replace the pump. Very rarely, very rarely. So it's always replacing the seal. That seal is, again, if it wasn't a leak around the body seams or something, then when you put in a new seal, it's like a new pump. In fact, if you go back before December 2000, the category was pump seal as the component, not pump. They changed that when they added monitoring, all of those other little splits around the pump body and so forth.
So we don't do that. I mean, if it's leaking, we actually apply a lock to the lock box that's been taken out of service and it's on DOR. So they notify us right when they're putting it back in service. We go stand by, they commission the equipment, we test it. If it fails, we'll tell them right then, this does not pass. You need to return it to out of service. It's still on DOR, clean it up, put a new seal, fix whatever's wrong, and we just put it back to that same delay repair. I mean, is there any issues with doing that?
The same thing for the valve. The valve it was already on out of service, it's already locked out and everything, so there's no reason to create a whole new tag.
Yeah, I don't see the...
That's assuming you can isolate online, which for the pumps you usually can. Valves, sometime, but not all that frequency. But yeah, a lot of times it's repaired during a turnaround. And then you come up from the turnaround and you're not going to get them to go back down because your pump or your valve's still leaking. That's, I think, is what Jerry was referring to. Not an online isolated repair, but coming up out of a turnaround where it would be very difficult to find that real quickly after you start up and then make them shut back down to get to it, if it wasn't isolatable online.
I was just kind of surprised by the new leak and the new 15 days.
Yeah. When as you replace things, it definitely makes sense. If you're just replacing packing, it's a little whooshier. But, I mean, you've done all you needed to do. The only way I would feel guilty about the packing one is if you inspected the valve before you packed it and there were some questionable issues in terms of pitting or a bent stem or other things like that. It's going to make it hard for even new packing to make a good seal. But you went ahead and did it anyway because you're getting towards the end of the turnaround or something. Then you might take your hit and say, no, we didn't do what we were supposed to do and it's leaking and we'll just take a non-compliance on that one. But if it was a clean looking valve and you did a reasonable installation on new packing, that's a new seal to me. That's the whole seal assembly. We know that's what, when you talk about the way they looked at check valves, they said, no, you don't have that stem seal, so it's not a valve as far as we're concerned. So if we go in and replace all that stem sealing in the stuffing box, the packing, and clean everything up in there, polish it maybe and do that, I don't feel bad about saying, you know, we replaced the key sealing element here, and if it's still leaking, then that's kind of a new leak and we'll track it to completion.
On a new valve, we do it that way. So if it goes on DOR
Mm-hmm.
and we replace it, the way we close out that whole delay repair is just putting it in the database. Once you delete that from we make that component inactive and the database no longer exists.
Yeah.
It goes away, but it doesn't have that monitoring that we talked about.
Yeah.
Okay, I see what you mean.
All right. We finished the first module. Thankfully, the rest of them are not quite this long. Yes, sir. I have no idea. I haven't been following that. I wasn't involved in the comments or anything. So I don't know. Is anybody here tracking that or involved in it that would have input on that? It's only been a few months, so I don't think it's dead. But yeah. Yeah. Basically self-reporting everything they need to estimate your penalty. I saw quite a few people out here offering fence line monitoring solutions in the exhibit area, so I don't think they're thinking it's dead in the water, but no, it doesn't. Vendors are ever hopeful, like the rest of us, I guess. Yes, sir.
As far as a DOR situation where maybe it was misdiagnosed, we had a situation where barrier fluid was leaking. It was actually put on DOR because they couldn't figure it out because it was hardened. And it sat that way for months, and then we went back to look at it because I wanted to use the pump, took the guard off, figured out it was a barrier fluid. Made the repair on barrier fluid, and then put a big huge light up and leaked my switch.
Yeah.
Is there any way to handle that beyond that? Or it's really not even an LDAR, it's just misdiagnosed.
And it was based on like visual dripping?
No, we used propanol as a barrier fluid, so it was reading.
Is propanol a heavy liquid?
Yes.
Okay. Wow. It's surprising you would get much of a reading with that, but I'm not sure there's any differentiation if it's coming out with a above leak definition reading, whether that's coming from barrier fluid or process fluid.
Is it pressurized silt line? We've seen the very fluid pressurized.
Yes, pressurized.
It sounds like you need to replace your barrier.
Well, I think that's what they eventually did, yeah. So it broke down to the point where it had light liquid components or vapor components in it. Yeah. Interesting. Yeah, I think that's a... Well, you did... What did you see? You said you put it on delay,
Right.
and then you fixed it before they went back into service because you determined what it was.
Well, they wanted to use the pump, and
Yeah.
I said, well, then we'll go back and look at it. Took the guard off, steamed it,
Yeah.
figured out where the leak was coming from, fixed it, put it back in service, ready. It's good.
That sounds like you put something on delay of repair. You repaired it before you put it back into service.
Right, but that's not much of a repair to say you did for So,
It stopped leaking. That's yeah. Well, no, I think it was your guys that were the acts of LDAR technicians that stopped it. But yeah, you didn't have to replace the seal. But I mean, you're not committing to replace the seal when you put it on delay or repair. Well, what reason did you use?
well, like I said, we did a big long write-up.
Yeah.
This is what happened. We figured out it wasn't even an LDAR leak because it was barrier fluid. So,
Well,
and included.
if you use the 6 month to upgrade the seal, again, that's
We used
okay.
We isolated.
Okay. Isolated is fine. You're fine there.
Okay.
I don't think there's any problem with that. All right, Chris, we need a new voice, new persona. Why don't y'all take a 5-minute stretch break and are we leaving at 2:30? Is that the next break? Do you have a schedule in front of you? 3 o'clock, okay. Take a 5-minute now and we'll have the next thing up to look at.
I don't know if I like this idea. Maybe I'll stay.
So triggering.
Question.
Hey,
You're talking about DOR, not just spare parts,
Yeah.
but just DOR in general for VV. Is a process unit shutdown definition, either you can have a unit like flatline and gas-free, which is zero manufacturing, right? or you can have a partial shutdown with some things still up, some things still down, but no manufacturing. Which one actually is if I go down to a partial unit shutdown, am I required to fix the DORs that are not out of service?
If it's out of service.
But it says like
Right.
if you missed the next process unit shutdown, it didn't say partial or full.
Yeah, it doesn't.
It doesn't. So that's why I'm kinda
It doesn't
curious
talk
if it's a
about it.
deviation if I can't get it fixed.
The language in there, if you can, I don't know, these sound like they're down for longer times.
These are the flat lines because they're gas-free. Flat line maintenance is going in.
Okay.
This right
So
here
that
is
one you should be
partial.
doing your
Correct.
DOR.
But I'm just curious
On the
about
partial one, if you've done that, I assume, because there's some critical repair that's needed, cleaning a heat exchanger, working on the heater tubes, whatever, that's causing you to derate.
Right.
And you're going to spend some time, the minimum time, getting that critical repair done, and then you're going back up into full manufacturing. So if you can
entire thing. Okay.
I've got a few of your emails off and on.
Yeah. It's a really good excuse.
Some out in the Mountain West, like Billings, you can't get within 500 miles. Frontier, 1590, whatever. I'll drive and find a New Orleans and find
All right, we'll get started here in a minute.
Thanks for dropping in, saying hi. I'll see you around the rest of the week, I'm sure.
Yeah. I'm moving.
You are? Where are you going?
Naperville.
Oh, becoming an official VP. Yeah. Oh, that's
Nice meeting you. All right, we'll go ahead and get started. You'll still make your 3 o'clock break, so let's do this real quick. Next, we'll talk about the VVA triple GA applicability, kind of what the implications of that's going to be. It's too loud, not loud enough. It seems loud in my ear. Okay. So as we've already kind of discussed, we know the effective dates for a lot of these requirements. Triple GA is going to be November 7th, 2006. Effective facility can be compressor or all the other fugitive components associated with the process. Anybody separate out compressors by themselves at their facility? No. If you trigger triple GA, it's probably not a bad idea to go ahead and isolate them and just bring in the compressor components instead of bringing in a whole unit. Mm-hmm. We've had this discussion multiple times, and it's mainly the stuff that gets ordered and the things that are required to keep the compressor going. I'm just cutting it off at those points. Some have gotten just to like the skid itself, and everything inside that skid is the compressor affected facility because the piping goes everywhere. But all the little, you've got all the instrumentation and pressure transmitters, drain valves, things like that. All that stuff would be lumped in. It's not a lot of components.
You'd recommend, what if the units applicable to the same rule, you don't want to separate it out, right? Or would you recommend breaking it out?
Depends. It's really up to you. If you have a really massive facility and it's going to be a lot of extra work to bring this in, then you'd probably consider the compressor. If it's not going to be a lot of effort, and eventually you're going to modify into it anyways, there's no reason just to bring the whole system in. References pretty much VVA like Triple G does. No real differences at all. We talked about that bottom statement. VVA, similar to Triple GA, except for you cannot isolate a compressor by itself. It's for SOCME facilities. Includes connectors, but that's been stayed, and who knows if that's ever going to actually get lifted. As well as the process unit definition. Which is this, which kind of did like the chemicals, where it was bringing in a lot of the tanks and transfer lines in between OSBL type activities. So if you're out doing your normal inspections, if you had to include a tank, and then all the rail lines and everything that go into that, inside that quarterly monitor, you're going to be all over the plant instead of just saying, tank farms, it's tank farm. OSBL, depends how you break that up. It could be a part of the unit, could be a part of the tanks. This would have lumped it all into that same rule. That's been stayed, so you don't have to really deal with that. It falls back to the VV definition. Like I said, no action to date. Was talking with a few people from actually a state agency, and they said that they're still considering this and working on it. It's not dead, but it's been, what, almost 6 years, 7 years? So I don't think it's going anywhere anytime soon. This has also been stayed. Let's see, capital expenditures. Added that definition, also modified kind of what the effective dates for those would be. These are going to be important when you're talking about your modification calculations to trigger into these rules, which we'll do some of the calculations here in just a minute. Who tracks the applicability of your unit? Is there like a permanent engineer, somebody that's just basically giving you guidance saying, hey, this is going to be VVA, you need to go ahead and do it, or we're going to modify into it, or you having to be proactive, looking at your component counts, figuring if you're replacing 50% of it, which figure that out through capital expenditure, but modification, tracking MOCs, number of components you're adding. If you're don't really know who those people are, who's tracking, especially modification, probably something to be looking into pretty quickly, because the older the unit is from when the initial construction date, let's say it's greater than 55 years, effectively adding one component would trigger modification. One net component. So if you're doing replacement in kind, something like that, doesn't really matter. And obviously there's a big difference from reconstruction and modification, which we'll get into. Like I said, you trigger the mechanisms for VVA and Triple GA through either new construction, which is going to be anything after those effective dates. Pretty cut and dry. I don't think we need to dive into that one. Reconstruction, also fairly dry, or cut and dry. It's going to be a cost number. If you're basically pumping in 50% of what it would cost to rebuild for a new unit, you're going to reach reconstruction. And then there's modification, which is a 3-part test, and where we find facilities a little bit more deficient in making those appropriate determinations. So new construction means that the owner or operator undertook the development of that process after the effective dates. In this case, like we were saying, November or October of 2006, depending on which one you're looking at. And it's going to be regardless of the size, the cost, or the source. Reconstructed sources, anybody chemical plants in here? Go through a lot of basically refurbing, whole batch processes, things like that. Reconstruction costs would be something to really pay attention to. because you're constantly going in and changing the whole process, or not changing the whole process, but changing out the equipment if it's not working right. Refineries, things with more continuous processes, you'll generally know that you're going to hit reconstruction. That's going to happen typically after a massive accident where you're replacing most of the unit. It's going to be a fixed capital cost for all the depreciable components, which is going to be everything as far as valves, pumps, compressors, flanges. So this is the big one. It's modification, which really affects everybody from the field service companies that are out here to the LDAR coordinators to the consultants. This is the one that's really hard to get a lot of really good optics on from a plant level. If you're managing the database, it's fairly easy because you can basically track the number of components you have over time, and if you're constantly increasing, that's one of the things EPA looks at when they do a 114 request. Anybody not know what a 114 is? So under the Clean Air Act, the EPA has the authority to just basically request information, and it's non-negotiable. They have some leniency on timeframes and when you can get it back. If it's in the middle of a big compliance period, you can say, give me 2 more weeks, and they'll probably say okay. But at that point, they can request anything. And it could be from just a simple backup of the database to a whole bunch of process information. Anybody remember the ICR? Who's involved in those processes? Information requests for the refineries. It covered fugitives, tanks, B1, just pretty much everything. Very complex process that came through because of the 114 and their ability to do that and the justification from a regulation perspective. The modified sources. So to be modified into this rule, one, it has to be under process improvement. Who can define and tell me what a process improvement is? Or who can limit and tell me what a process improvement isn't? Pretty vague. It's basically going to be anything you're doing to your plant. You're not just doing work for no reason. So you're going to have some sort of impact for a purpose. Whether that's somebody installing a couple of valves to have better access for sample systems for their controls, things like that. That's affecting kind of the operator's ergonomics and safety aspect potentially. That would be a process improvement. Constitute a capital expenditure. We'll get into capital expenditure. Basically everything you're adding, whether it's a simple flange, a 1/2-inch valve, a 36-inch valve, small pump, big pump, doesn't really matter. Everything's going to come with a cost. And to get a capital expenditure, it's got to meet a couple of criteria based on when the unit was normally built or first built. We'll go through an exercise to make this a little bit more clear. And the last one, modification has to have emission increase. If you're doing replacement in kind, it's net zero, no emission increase. A valve is a valve is a valve. Pump's a pump. Doesn't matter if it's a 50 GPM or 2500. If it's on this, you're replacing 1 and 1. Those numbers are net neutral as far as emissions are concerned. So you don't meet it. You have to have some sort of increase. One flange would be an increase in emissions from an EI perspective. So it doesn't take much, but it doesn't account for different types of components either. So if you had a control valve, which typically have higher leak frequencies, versus putting in a gate valve, doesn't matter at all. This is one of the very big question. If anybody here from either service provider, industry has any buy-off on or guidance from permitting groups on what the time period should be. We had a couple discussions. Should you go back for modification 2 years? Should you go back to the effective date of the rule? Should you go back to when the unit was constructed? There's not really anything clear and cut and dry to say one way or the other. What does seem to make sense on the most conservative would be just to go back to the effective date of the rule. Because there really wouldn't be a reason to be tracking modification and all this other stuff without a rule that's more stringent than it. So if you go back to 2006, that's the most conservative. Some places go back 2 years. Whatever that is, you kind of need to justify that within your own organization. Can't really help you. We haven't seen much feedback from what the agency's expecting, both from a federal or state level. But if you do have specific examples from your permitting process, that would probably be a good thing to, or at least a benchmark for your own group to be using. EPA was kind enough to define what process improvement is in the general standards of VV, or sorry, of 40 CFR 60. Routine changes made for safety or occupational health requirements, for energy savings, better utility, ease of maintenance and operation, for correction of design deficiencies, for bottleneck removal, for changing product requirements, or environmental control. Well, what's not on that list? That pretty much covers everything I'd want to add a component to my process for. So you don't really have any outs, but we did say, you know, if you're doing kind of routine maintenance or just small things that really aren't designed specifically for those requirements, or if it's replacement in kind, you're in the clear. Don't mess with it. Don't need to count those. One of the things that would be kind of hard to do, so if you're tracking modification over time, if you do have a couple instances where you're looking at, or maybe you've kind of classified what a routine maintenance is, maybe you're working on a sample system or changing up a control valve configuration a little bit, just nothing really changing as far as ergonomics, health and safety, environmental, not really affecting the process. It's just some troubleshooting. Yeah, no problem. You might want to classify that differently and set those components aside in some form so you can back calculate, pull those out if you're kind of adding them up over a period of time. Netting possibly for emission increase evaluations, but not an EPA sanctioned. I think that netting, they typically go back 2 years. Equipment subtypes are specific for emission factor comparison. One of the simplest way to approach, the calculation aspect of it, control valves and large equipment typically cost a lot more than the smaller ones. So it's not a bad idea to lump just things in baskets. You know, I've got 1/2 inch to 2 inch, probably going to be around the same cost price, but when you go from a 2 inch to a 6 inch to a 12 inch to a 36 inch, it's exponential. You add a control valve or a pump in there, those costs are going to vary. So it's easier to kind of isolate them, but you can just lump all valves, have a generic cost, and figure out if you would even trigger a modification. You can get down to the cost of one specific valve versus another. I don't know too many people that have done that. I think they just kind of group it. But anyways, what we're going to try to find is whether or not the total cost of the new or replaced equipment components, really long acronym that really doesn't mean anything, exceeds P, which would be the current cost of, or the capital expenditure limit. But this is just a function of the value of the facility or that unit at the time. So we do that in a couple of different ways. It's a little bit easier, a lot of words, but this is kind of a simplified approach. So ultimately, you start down here at the bottom, where you just figure out what the number of years are between the current year and the year of construction. Or in this case, your effective date, if it's the way you want to go. You'll plug that value into this equation, which will give you the scaling factor for B, which is basically going to be your depreciation value, or your index. That how much is my current value of the facility worth 55 years ago? It's going to be close to nothing because depreciation after 55 years from the IRS taxes is 0. So anything older than 55 years, if you add something tomorrow, you triggered from a math basis. And if the EPA finds or does the digging themselves, then that'd be pretty easy to do. You don't really report construction dates on any of your routine reporting, so it's going to be very difficult for them to know, but they can look at when that facility was more or less built. Largely, I would look at like crude units, things like that. CATs, cokers, some of the other ones probably have been updated, modified a lot sooner than the older crude units. Once you get that, you kind of find your factor. Do we have any oil and gas guys? Oil and gas companies, people who do this for oil and gas, triple K. This factor is 4.5 for you. It's not the same as the refinery. It's not the same as the chemical facilities. I believe Oklahoma has a really nice summary sheet of what all those values are. If you would like it, just send me an email. After you get all this done, you figure out your your schedule based on the years, your factor, what you're going to be using. Go in here and you plug it into what your allowance is going to be. And then R is really just a function of what you're adding, what the cost of that equipment is. Or basically the cost of the equipment, because you're doing the cost value today. You don't worry about cost, what the cost was in 1975. You're figuring that out by using the depreciation. So when you're doing your calcs, just whatever engineering, procurement gives you as the cost estimate, that's the number you're going to be using, plugging in. You figure that out. When you get to that point, basically if P is bigger than the cost to replace, then you would have triggered modification. If not, you don't have anything to worry about. You don't really need dollar signs and figures to do this. You can do it just making pseudo numbers. So if you just did valves or flanges, things like that, and you made just a generic cost, you can figure out how many you need to add before you did trigger, which can be valuable if you're going to be proactive about screening for this modification, if you think it's close. Has anybody done this calculation for your facility? A couple of people. Have any issues? What was the biggest one you had? Mm-hmm.
No, I mean, I think the biggest thing was I had to realize that the capital expenditure dollars needs to exclude a lot of it's the actual regulated component used in the regulation, not your manpower or all that stuff. So that was the hardest part.
Yeah. I don't know if anybody heard in the back. One of the things to make pretty clear with this, the only cost that you need to collect is the actual cost of that component. So if let's just say you're going into a turnaround and you approach engineering and say, hey, what's this costing me? They're going to say, oh, it's $52 million. Like, that's great. I just need, what does it cost me for my flange? What does it cost for my valve? What does it cost for my pump? Nuts, bolts, man hours, all that is excluded from this calculation. So you got to eliminate some of the noise, because the man hours is one of the things that adds up the most, aside from like buying a vessel. Doesn't count insulation, doesn't count a lot of those other things.
You do this per project. 3 years down the road, you have another little project.
Generally, I would do it for every project, because as time progresses.
Previous project has.
That's the big question. I think it's a good idea to assume that it is additive and not just isolated in time, because if you took that approach, you'd very rarely get to that point where you're going to trigger. And if I had any suspicion why EPA even has modification in there, it's not to prolong your chances of triggering. So they would probably look at it cumulatively. And like we were saying, that could be 2 years. It could be a year of modifications. We don't really know. That'd be some standard you'd have to talk to your permitters about what is reasonable, what would they expect. Reconstruction's like a 2-year process, so that's where 2 years kind of is assumed. It's from the reconstruction guidelines. Does anybody have any questions on this? If I had a whiteboard, I'd go through some examples, but I don't, or paper. If you do have questions, just let us know. Be more than happy to answer them. Okay. So as I was saying, anything over 55 years, that dollar value to trigger gets really small. And what you can see after we plug in these multipliers, so if you're 1 year old, you get 12.5%, you're good. Come down here, this is starting to approach 0, and as that number gets smaller, so does your dollar value. Up until 55 years, at which point it's negligible. It doesn't really matter. One of the interesting questions had a minute ago was concerning a unit that triggered VV through reconstruction and whether or not to start my initial time clock from when it was originally built or the reconstruction date. I don't know the answer, but what I would think would make sense would be to start at the reconstruction date, because effectively you're saying you rebuilt your whole unit more or less at a reconstruction period. So starting your, and this would mainly apply to chemical facilities, I have a feeling. That seems logical from just a progression of where you would go, going back to when it was originally built, and then you rebuild it, basically. Doesn't really make sense to go back even further.
You're looking at the unit.
Mm-hmm.
My only part of my unit is subject to the requirement. So I've got a wet side and dry side. The dry side is out of the refrigerator. I have projects on the dry side that increase or alter the value of the unit. How does that play into something like this?
I would go back to the emission increase side. So the emission increases that are going to be subject to LDAR or VOC or HAP fugitive components. Right. What is kind of vague about this, or is kind of misunderstood a lot like heavy liquid requirements, it includes all fugitive VOC or HAP fugitive components that, you know, you may be exempt, but if you're adding heavy liquids, things like that, let's say you're putting in a new coker, all those heavy liquids would have to be included in this as well. It's a little bit harder because a lot of people don't inventory them. But it does have an emission factor. You do account for it in your EI. You would be bringing those in as well, part of this calculation. Getting a baseline to what that is to, you know, figure out the net differences is going to be a little bit more complicated because you're not tracking in your database like you do gas, vapor, light, liquid components. Everybody hear his question? Okay. This just goes through some quick examples. Using the database, we just dump stuff into Excel. And we start kind of counting, you know, we got our compressors, flanges, connectors. Again, capital expenditure. Under triple GA, you can exclude your compressor as its own unit. So you can just say, my compressor's it, and everything else I don't have to do this capital expenditure for if you want to isolate the two. And it's completely fine doing it. There's no issues there. You might want to talk to your permitters because that could change how permitting's done a little bit. Under your Title V, you might have just the unit, and then you're adding in a compressor underneath that unit as something completely different. So there might be some updates that have to occur, but again, that's probably fairly easy to do, although I don't think revisions take too little time. I think it's quite a process. But in this case, we're coming over here, we're looking at total counts. You know, if you want to do a quick and dirty, which is really what this is, we kind of lump things in baskets. Like I was saying, we have a 1.5 inch PRV, a 2 inch, 2.5. You could do that with valves. You can do that with pumps. I'd probably just leave all the same. There's so few of them unless you have some pneumatic pump or something that's fairly cheap compared to big centrifugal. One good thing too, if you have a component that basically is a sealless system, so mag drive pump, something like that, that doesn't have an emission increase, you would not count that in this capital expenditure calculation. You come over here, you get all your dates, everything in line. Come on this side, you figure, okay, this is the new stuff I'm adding, kind of tally all that up, multiply what your costs are, and then you can put everything in the equation. And once you get it all set up, it's really quite simple. It's just getting the data in line that's really the hardest part about this whole process. Those of you that have access to the databases, whether field service or site operator coordinator, you'll have the database in front of you. You know these changes. So if you are curious on whether or not you modified, it'd be pretty easy to go through and look at differences over quarters even, if you're adding a bunch and removing a bunch. One of the things that would be very difficult with that, let's just say heaven forbid, because I know these are perfect sites, that you just missed a line in your initial applicability and now you added 30 components that have always been there and they've just never monitored. Those would kind of get flagged to be pushed into this calculation when they really shouldn't be. Those should be a deviation on their own accord of mismonitoring and other stuff. So when you're looking at the database, just kind of be careful unless you know it came from an MOC or some process that was within that time frame, just to be lumping them all into the modification calc. Basically all the results from that sample, we took everything, we have a cost per component, we just multiply it straight across. This is going to be our new components, and down at the bottom we take that equation over here, this one, plug all the data back in, and I think I have the answers. Nope. Anyways, this will shoot out whether or not you become subject. And this, like we said, can get very complicated. If you want to do a cost per single component, it's going to get excessive real quick. You're better off just lumping things together. If they're within $100 or even $1,000 of each other, just throw it all in the same cost. It'll give you a rough napkin-based calc that if they want to, EPA or somebody wants to dive into, it's going to take a lot of effort and a lot of time to get into the nitty-gritty of what that would cost. Any questions on capital expenditure? Like I was saying, just to reiterate, don't forget the components, heavy liquids that are not traditionally in your program that you don't have inventory. Those have to be in there as well. Replacement in kind, things like those, possible impacts to the process unit. Really vague. If you do define routine maintenance, I'd write that and probably do that uniformly without my organization, or have some uniform guidance on what routine maintenance is. Anybody field operators in here? You were. Routine maintenance. What would that be?
It's pretty much just, if once the equipment's in the unit, it's maintained by routine maintenance. You know what I mean? So capital projects, that's the stuff that's non-routine, the installation of new equipment. Once it becomes a physical part of that unit, unless you're significantly changing the design and upgrading it, it's considered routine in our eyes.
Do you know of any examples where a routine maintenance wouldn't also meet these requirements?
Yeah, that's the problem. I mean, about everything's going to go in there.
Okay. He's in operations once, so we'll ask the question. We have any regulation geniuses in here? How about really good with regulations? Who can guess what the compliance liabilities are for VVA, GGGA versus GGG-VV? If you're under consent decree, I would say next to nothing other than some record keeping. But overall, they're very small. We only have a few slides on this section. Oh, well, that's not going to work. So we kind of lump this in a couple of different categories. We have a direct cost and emissions. Basically what we're going to do here is look at emission reductions based on the new requirements. So if we do this, would we see an emission reduction, which is the whole reason to have these regulations triggering to a more stringent rule. And then compliance liability. Compliance liability really is a kind of a catch-all for record keeping, all the little nuances that you're going to have to keep up with to demonstrate compliance. Our scale goes from -10 to +10. If it's negative, there's really not a problem at all. If it's positive, then it means there will be an increase, whether that's in the emissions, whether that's in the compliance liability, and cost. So for instance, a good example would be on the liability side, one of the big changes EPA missed in the first attempt was not adding record keeping requirements for visual inspections on pumps. The new one, they just say you need a date that you do the inspections. Pretty simple, but if you're not doing them, then you're out of compliance. It's going to have a very low compliance liability. It can have a very low cost, and you're not saving any emissions. Just looking around and really looking at something's not going to have a big factor for there. So we broke it down, and this used to be extremely long. We distilled it down. This will be the last slide for this section. Go ahead and dropping the leak definition down from 10,000 to 500, and also the pump leak definitions. Actually, it does have quite a substantial cost, mainly geared towards the number of things you're going to have to start repairing. A 10,000 leak versus a 500 leak. How many 500 leaks do you have at your facility? Anybody can shout out a number. Not a lot. How many 500s do you have? Or did I already say 500? Okay, 500 you have a lot. How many 10,000s? We got a lot of 10,000s in here? Not that many. Increased maintenance, increased involvement on your data admin, your field service guys going back out there doing the re-inspection, things like that. So that's where the cost comes from. You got a fair amount of emission reductions, but not a whole lot when you actually put that difference into the calculator. You know, you put a screening value of 500, put a screening value of 10,000 or peg factor. There is a difference, but you're also not talking about your entire population of components either. So it's not a huge factor there. And then your compliance liability goes up. You know, you're going to have more first attempts at repair, more final repairs, potentially DOR, all kind of the documentation things that fall underneath that. Added in some sample system requirements. This is really specific if you are already under some of the regs with sample system requirements. Sample systems aren't cheap, so there's a really high direct cost with installing those. Emission reductions, probably not a lot if your current sample system worked out all right for you. And then the compliance liability, it's kind of one of those big issues. EPA is going to go out there and look for open inline sample systems. They may do some monitoring, but they're going to look for more of the cosmetic things out in the field. Valve initial monitoring, again, more technicians. This is more in reference to the 2 consecutive months of all the new components, things like that, that we all more or less disagree with, especially if you have existing history. But there's a huge cost to that. Really no reduction because they weren't leaking before you triggered anyways. Compliance liability subsequently increases with the cost. Follow-up monitoring, you will get some initial cost on that just because you're finding more components that are leaking. You do see some emission reduction, but again, we're not talking about a lot. So if you're going and doing 1 month at 500 and then you go back the next month, it's nothing, you're not talking a lot of difference, especially if it's just maybe even a few hundred ppm or single digit ppm difference. The calibrated drift assessment, you know, really it doesn't take much time. Who can do a drift assessment in, 10 minutes with the documentation, making it nice and pretty, scratching out initial in it where it's illegible, which by the way we do look at. If we can't read it, it never happened basically. There's record keeping has zero emission impact. That's just something that you have to do. Along with the record keeping, there's also that compliance liability. So if you're not doing the 3 drift assessments, you're not doing it at all, there's going to be some just record keeping issues. Delay or repair, you do see a higher direct cost. Again, low leak definition. You do see a little bit more emission reduction because of the low leak definition, and the compliance liability is really not much different. It's pretty simple form. Everybody's been under DOR for probably some time. And then record keeping. Again, like we were saying, there probably is a direct cost because that takes somebody's time. A little bit harder to quantify when you're talking about just maintaining records, reporting, things like that. But the things that they did add do have a lot of compliance liability. And again, you're not going to see any emission reductions from killing trees and consuming computer energy. Should be an increase here. And that's going to be basically the compliance liability. Anybody have any questions with the triggering and what that would kind of look like? If you have a consent decree, you're pretty solid. You're already running at a 500 or something. If you're HRVOC, you're South Coast, AQMD, Bay Area, you're already running low leak definitions. So you're not going to have to worry about too much. You're just going to have some record keeping items to take care of. I think some people are looking for consent decrees. Those are coming up. If I lose my voice, I'll tag in Buzz. Is this echoing? To anybody? Okay, it's in my ear. It's definitely there. Let's see if I can get this working. That's unfortunate. Anyways, we'll go over some recent consent decrees and ELPs. Who's not subject? Let me ask that question. We got one that's not subject to. Okay. It's probably more applicable to y'all. The folks that already have it, you might want to be paying attention more towards the termination end, and also kind of what the recent trends are going to be if you're not subject or keeping up with it. So we'll talk about the historical context on the EPA's chemical and refining CDs. Kind of the paradigm shift that we're seeing. We've all kind of been aware over the years how EPA's changed and added in a lot of low leak technology, things like that. And then overview of the more recent ELP requirements. I don't know if it said it. Yeah, Enhanced LDAR program is ELP for those that may have questions about it. Okay, if you're a refinery, EPA's pretty much covered almost everybody. There's a few small operators that still do not have consent decrees. I think some of Chevron's neighbors don't have one. And then there's a few in California that don't have it, but they're also underneath a lot of kind of really crazy regulations already, so it wouldn't serve much purpose. San Joaquin and the Southern California area. So continued LDAR non-compliance for the second. Anybody have a second consent decree? Anybody help manage a second consent decree? That's pretty fortunate. A lot of the second consent decrees basically came in and EPA did an inspection and found that they're still not getting their stuff correct. And that could be everything from inventory, leak monitoring wasn't done right. Let's see. Also, their opportunity to impose the low leak technology, which is a lot of the refinery second round consent decrees. Some of the chemical plants, instead of second rounds, they're getting their first ones with the low E stuff. We've gone to more of a preventative maintenance. So what we want to see, which gets years ago, it used to be thought that this was going to be very expensive, but much like computers, low leak technology has come down pretty substantially in cost. It's not that difficult to get a low E compliant packing valve at a value that's similar to what you would have paid 10 years ago, which is good for us because we have a lot of these requirements where we're having to install low E valves, and in some cases they suggest connectors, which I don't know of a low E connector. And then eliminating potential leak sources. So if you go to dual mechanical seal or mag drive type seals that don't have an external seal system. Anybody use mag drive pumps? Got a few. I think one of your neighbors in Corpus has one. They work pretty well if you're interested. Apologize, these aren't actually the updated set of slides that I've made. This really should say 2015 and where we're going. So all the refineries are pretty much hit pretty hard. EPA may be going in and now and again and verifying that they're in compliance with their consent decree. But at the time, they're not really doing a lot of traveling and going out and visiting the sites. They will do the 114 requests and basically track a lot of things through the database. Later on, either tomorrow or Thursday, we'll kind of talk about why they prefer the database route versus spending money and going in the field. But for now, we're going to land on this. Big focus on chemical industry. Who can guess what the ratio of chemical plants affected to LDAR versus the refineries are? Somewhere around 10 to 1. that's a lot of opportunity for EPA to come in and do some investigations for non-LDAR compliant facilities, consent decrees, get the emission reductions down, which is why we're seeing a lot more pop up. And now the oil and gas industry. Triple K facilities for a long time, kind of went underneath the radar. There's even more of those than probably chemical plants. There's some in negotiation at this moment. So it's on the horizon. Some of the big things that we are seeing is kind of a general classification, expanded LDAR personnel definition. So basically right now they're saying everybody who has an impact with the program is going to be LDAR personnel. Some of the older ones were basically monitoring technicians and operations, pretty isolated. A lot of the background of why that happened is there's so many people that actually do impact the program. So if you've got some maintenance group that does the maintenance on the equipment, but it's not considered part of operations, which the other definitions would have required training for, then they may not be getting the same page. They may not know that you need to notify LDAR immediately, hopefully they do, to go get things repaired or that it has been repaired. So it's just an expanded. One of the reasons why that really is a big issue is just for training requirements. Who does the LDAR, has like a generic LDAR training for anybody to get into a site or their specific site? Got a few, yeah, quite a few people are going to that approach. We're saying, hey, you know, regardless, we're covered. We're going to have people come in. They're all going to have some sort of introduction. Generally, it's something soft. You know, you see tags, tag box. Open in the lines, you see a leak, tell somebody. But keeping it very simple. Also is really probably nice for situations where you have contractors coming in or a turnaround, especially insulators, painters, because we all love those guys. Giving them the kind of the awareness, like, don't tear off my stuff and don't paint over it, because that's just a huge hassle for everybody else. Or if you do, let me know, because at least then I know where it's at and I can fix it. Low leak definitions and even lower initial attempts at repair. Also bringing in some more components. Had a question on dual mechanical seal and consent decrees. I'll follow up with that person later. One of the things they have brought into the Dow consent decree, for instance, they did bring in sealless systems like mag drives and dual mechanical seals as exempted versus the older ones that say nothing about them. So they're kind of expanding or doing at least subtyping of components that would match what the regulations are doing. 12-month remonitoring on all leaks under skip periods. It's largely going to be applicable to chemical facilities. Most of the refineries are strict quarterly. Valve drill and tap required above 250 ppm. We've got Seal Tech folks in here. Repair guys, y'all do a lot of those. Find them effective, or they pretty much trash the valve after a turnaround? That's the other side. Most of the time, if you're doing the 2 drill and taps on a component at 250, by the time you get to the point of needing to operate it, you're going to have to be replacing it at a shutdown. Which, do what?
10 years ago,
yeah, it's easier, and it's frankly, as much as drill and tap and some of the safety stuff costs for doing that, it's cheaper to replace it if you can isolate it. Mandatory replacement with low leak technology. Do we have a site under any low leak requirements? Got one? Okay. Any sites that are subject to replacing components with low E? Legally required, not voluntary. Okay, we'll get into some of the kind of the gray areas and really how that becomes a huge impact. A little bit of continuedness. Certified low leak technology, there's a bunch of different definitions out there. Generally, it's just a guarantee that a component's not going to leak for a period of time under a certain ppm. Whether that's going to be valve packing, the valve itself, or other type of components. Some of the additional requirements that they're added is the replacement of existing equipment after like turnarounds. And in this case, up to 10% of the valves. Some of them get pretty complicated with how many you actually have to do based on what's being affected, how big the facility is. That one gives me a little bit of heartburn. What's the average leak rate probably in the room? Anywhere from 0.5% to less than 2% probably, I'm guessing. So conservatively, we can say 98% of your stuff probably never leaks. It never has in its entire life. Replacing 10% of that seems a little crazy. But that's some of the language, if you're not careful, gets added in there where they don't limit it to just the stuff that's leaked previously. And some of them, they've said, you know, if it leaks twice within a certain period, you're going to replace all those. It's well and good. I completely understand that. Things that leak typically leak more than once over a period of time. And then we have the connectors, which, anybody have a low E connector? We got Flex Italic, and I know they're not going to give you a guarantee. Some of the other ones probably not either. General requirements. Anybody have a directed maintenance? Repair verification, same time as the inspection. That's a bit of a hassle. Some of them do the quasi, which gives you 24 hours to come back after they do the repair, which makes a lot of sense for the most part. You know, if you're out there, you're working on the valve, you're kind of squeezing the guts out a little bit, you could get a high leak if you're immediately doing it. And you could be there for a while with the directed maintenance. A lot of enhanced QA/QC. They've increased the stringency of the audit frequency. That one I feel like is quite negotiable for the most part. If you're good with the every 2 years, they may keep you on that cycle. If you've got an existing consent decree, if you have a new one, I still think that that's one of the areas, as long as you're doing them. Not doing them is not negotiable, but the frequencies should be something that they'd be willing to work with the site on. Expanded record keeping, reporting, a lot of that comes in with the low E side. So you're going to have to demonstrate that you're in compliance with the low E stuff, especially all the new equipment being put in. Replacing, you can tie it to the repair record, but initially tying all the new stuff in your database can be probably a little bit of a challenge. And also getting the groups to communicate. Working with the site now, they say they have these approved vendors, but the components that they're installing are not on that list. And that's because there's a big disconnect between procurement, the operations and engineering that are installing this stuff, and the environmental group. So when you're doing the record keeping, you're really having to tie in like an entire process just to ensure that you have the records to be able to say these are certified low leak technology components. And then heightened stipulated penalties. They also changed the stipulated penalties last year for the federal regs. Anybody have a DOR limit? Not too many people in here. The new consent decrees have kind of either a fixed or a sliding. So if you're in the middle of negotiations and you're probably semi-close, they may allow more DORs for a while, but after that turnaround, that's going to drop pretty substantially. Extraordinary repair, redefined. I think there's some questions earlier on that. Maybe some of the ceiling groups here can tell us what they think is extraordinary repair versus some of the others. Obviously, with the drill and tap requirements, they don't think that's extraordinary. But things like wire wraps, line freezes, I would generally consider those extraordinary repairs. Regardless, you should have that at least documented within your written plan. They have, as I was saying earlier this morning, brought in the skip period allowances. So, if EPA hit their goal within 10 shutdowns, 100% of your facility or unit was low E, and you're running a 0.2 leak percent, there's no reason for you to keep going back quarterly. So you get to the point where you're saying, okay, I can come back every 6 months, every year, or biannually. Which makes sense. It's kind of a give and take for the extra cost and effort you're putting into limit your fugitive emissions. They're giving you a little benefit. Historically, the stipulated penalties were based on kind of an event. EPA changed that to an event versus time. So let's say you've missed a component or you missed inspecting a component or something. That's going to be based on the number of days you missed that, not just that one event. So that, more or less, you're going to have to track when you get down to the actual paying those penalties. Excuse me. Valve repair. We've kind of covered all those with the documentation aspect. Let's see, some of the more recent ones, I think Flint Hills was last year, Any Flint Hills people in here? Port Arthur? Not Port Arthur. They settled theirs, I think that was last year, early last year, about February this time. You know, kind of an overall summary. Includes B1 flares. Let's see. They did add in VVA. They have your HON and MON units. Let's see, DuPont in West Virginia. A lot of the stuff they noted was failure to monitor pumps, valves, and connectors. That could be from you having those tagged in the database being messed up, or just not having them in your inventory and they should have been, which comes down to applicability and speciation, other things that we'll talk about later on in the training. Let's see, failure to identify and report equipment containing HAPs. I kind of think that that falls underneath this category of 1, but they line item it individually. Open-ended lines. Who's got no open-ended lines? Yeah, it's LDAR. There's always going to be a non-compliance event, especially in open-ended lines. Unfortunately, we're in the position where we just find them and get the ding for it, but we have nothing really to do with them. Failure can require pressure tests. This would be underneath a different requirement, so you can not monitor your component, but do the pressure testing for it. Specifically stuff like UTMs. You know, if it's on a flare line, hot radiation, things like that, you don't want to put a technician up there on a frequency. But it comes down, you take the component off, you do a pressure test, see if it passes, put it back. So if that was in the written plan, they weren't doing that, then they were finding them in violation of that aspect.
Would you say that again, please? What were they doing?
Pressure testing their equipment. So there's options in the regs where you don't have to do your inspection if you're gonna, let's just say you're gonna put somebody in unsafe conditions. You can take that component out and pressure test it to say that it wasn't leaking, and that you know it's not leaking. It's one way of doing your inspection without ever doing the inspection.
You mean like a PRV?
No, it would be a PRV. It'd be like a valve, probably just typically a valve. I don't think you'd do it on your flanges without pressurizing the whole system, but you can take a valve off, test the packing without it being in line with the whole equipment.
For
Yeah.
batch units, you can pressure test the entire unit.
Yeah, in the batch you could do the whole unit. But you couldn't pressure test like a flare line because it's got an open end on the other side. But you can take that component off and...
I was thinking maybe taking a pressure relief valve off. But they,
That's testing the relief pressure, not the air tightness.
Yeah. You're mainly probably going to do that just on valves. Country Mark has theirs. Any Country Mark folks? I don't think so. Okay, open-ended lines, again, performing method 21. A lot of the audits are driven with comparative monitoring. You're not going to find probably an audit requirement without comparative monitoring. And the reason why is most, if not all, the consent decrees are driven from non-compliance with method 21 on top of overlooked components and things. But having bad monitoring performance is what initially got the whole ball started early on with all the refineries. You know, some of these are pretty soft. Failure to tag a leaking valve. Yes, it says leave a weatherproof valve with all the information on the valve. Not really hurting emissions, but it is a compliance requirement that if you do have one, HRVOC specifically does reference that as well as one of the things to look at in their audits. Any current leakers, you go look at their leak tag to make sure they have them. In all the years I've done audits, I've found one instance by accident where it was a leaking component that did not have a tag on it. It's not something I'm going to go out and look for. I don't really feel like it has a huge impact on the environment, but it's something that they can do if they like. Again, failure to identify all the components. Probably do a root cause analysis. That could be bad P&IDs, bad communication between engineering and operations, or engineering and environmental, or just environmental. A lot of different things can go in there. Failure to submit semi-annual reports on time. I hope that doesn't happen. I mean, those are pretty static. Let's see, again, going to solution INEOS. Method 21, violations, improper leak detection equipment. That's specific. Who's chemical in here? We got a handful of chemical. Anybody do formaldehyde? Formaldehyde at your site? You do?
I don't, but there is formaldehyde.
Okay. Okay. So formaldehyde, who uses a FID detector? Probably everybody should raise their hand. Go ahead. For the most part, everybody's going to. However, a flame ionization detector is not going to work on formaldehyde. The response factor is above 10, which method 21 will not allow. So you're going to use something like a cathodic oxidizing detector, photoionization detector. Probably a PID is the most common. TVA has a dual detector where you have both in the same instrument, or you can go get a PID there or a catalytic oxidizer for less than $2,000. They're pretty cheap instruments. But if you're going out and monitoring formaldehyde, that's not going to work. You can't use an FID. It's not going to make any sense. The readings are going to be all over the place. I was at the site, and the site contacted, and I had a pretty good laugh because the EPA auditor said you might as well just hit it with a stick to do your monitoring, which I thought was pretty creative for somebody who probably doesn't do a lot of monitoring themselves. But pretty interesting. Failure to identify unsafe and DTM. I'm a little fuzzy on why that's actually there. That's either they say they have them but didn't ever document them but still monitored them, so they're just not in a plan, or they just don't have those components in their database at all and didn't do anything. But again, I think at least for the DTMs that would go under failure to monitor. Well, I'm pretty sure it's not a plan based on the third one. Anybody not have an LDAR written plan? That's a good answer. Some form or fashion have one. I could disagree with it, but as long as you have one, you're going to meet a lot of the federal requirements that tell you that you need something for your DTMs, you need something for your UTMs. So just have a plan in place. Teva Pharmaceuticals, so bringing in a lot of those guys. We're getting into HAP, batch operations. I think a lot of that becomes into, let's see, again, kind of probably test methods. That's probably meant to say not doing method 21 correctly. Failure to properly implement an LDAR program. I have no idea what that means. That's quite vague. Probably going to be something component identification, doing the monitoring, kind of all ties in together. SABIC, not identifying the components, not monitoring them, open-ended lines, compressor seal leaking. I'm assuming they documented it, never fixed it, and never told the LDAR people, and then EPA came in and said, oh, it's here, and then followed up with the maintenance log and said, you've had this leaking for a period of time, you didn't do anything. Thermal oxidizer not working, that's going to be your control device. Incorrect calibration gas for method 21. I mean, unless it's expired, or just you're using like 100 to calibrate your 10,000, I don't see how that one would be anything common. Again, we're finding a lot of trends here. You know, it's going to come down to open-end lines, method 21 implementation, components, and then some records. Records is going to be kind of the end-all, catch-all for all of these requirements. So findings of violation, which is going to be a little bit different, so notice of violations and some of the other acronyms. Open-end line, 16 instances. I feel like that's unfortunately still one of the more common ones we do find. Overlooked components is going to be another one. Failure to tag leaking components. There's a lot of stuff to review during a consent decree audit. Going out and looking for leak tags, that's something that your database is tracking, going to prompt somebody to go out there anyways. It's not a huge concern, but they do happen. Method 21 non-compliance. That's probably a real good way to be getting a lot of attention. If your monitoring is not solid, EPA is going to notice that really quickly, especially if they're out there. You're probably going to be approached. Mismonitoring, it happens. It doesn't happen very often anymore. A lot of the databases out there are tracking them really well. Occasionally you get little bugs. You talk to your leak DOS guideware, any other folks, and they look through the issue and they find the bug and they try to fix it in their next batch of updates, things like that. But the count's going down versus, especially if you put this on an opportunity basis. So if I'm doing 100,000 inspections and there's 14 I missed, that's not a high percentage. You know, you're 99.9997. Failure to install proper seal systems for compressors. I mean, that gets into a design issue, something that us as LDAR folks are subject to, but that needs to be caught on the front end in the design phase. So if you're going through kind of an upgrade, things like that, you need to make sure that the engineers and the people designing these systems are trained well enough to know how to make a compliant system. Failure to report or document violations. Who thinks you report open-ended lines in your Title V deviation report? Everybody should raise their hand. If you don't have a Title V, it's not required within the NSPS regulations to report those, but imagine you have a state agency that's going to require you to do them. It is kind of an individual case-by-case basis, but you're going to have to look at permit conditions and the state side. Failure to record CVS inspections. Who does this by paper? Anybody still do it by paper, or they have it? Yeah. It's one of those things like paper gets lost, database is a little bit cleaner and just documents it. But again, you have to, you should be able to do it in the database because you should have an initial inspection anyways, unless you did that by paper too. But eventually coming around circle to electronic database is going to make things a lot easier. Your guys are out in those units 4 times a year, on average probably. Should be pretty easy for them to, when they're on top of the towers looking down, when they're doing the catwalk on the fin fans or any type of process, to be looking at those closed vent systems on a frequency. So it wouldn't be that much effort for them to log it as well. Has anybody had an opportunity where a leak wasn't fixed after a shutdown or just got missed? It happens. It's pretty unfortunate, and there's not a lot of wiggle room for not doing it. When I was filling in for a site, we had one where they were asking us, this is before turnaround, what kind of repair they had to do. And I was kind of taken back by the question. Like, if it took a process unit to shut it down, I don't think you can just do a quarter turn and pass this. But we were getting close to finishing the turnaround, so I mean, you end up building a giant clamper on the whole thing and killing the emission source altogether, or replacing it. But those can get kind of hairy, and typically those are more last minute, 24th hour type situations. Leaks from compressors, pumps, more that's record keeping and things like that, or failure to identify them. Install closed purge systems. More or less I would assume that's just going to be, you're not going to have a double block and a bucket to pour your sample into. I don't really understand what else that could be. Or instead of an open-ended line, they did a closed purge. Failure to implement LDAR program. That kind of goes back to the what's a process improvement. Pretty much everything falls underneath that category. Failure to control HAPs from wastewater. I can only see that being applicable if your HAP content was high enough to trigger it, which it could be. Likely something that's going to be subject underneath chemical facilities. Excess number of components monitored per day per technician. That's not really, it's more objective, that statement. I think you have to parlay that one in with failure to implement method 21 for that to be something that sticks really well as a group. But if you're doing a bunch of connectors and you're doing, 2,000 valves in between and you get a total of 700 components, probably not that big of a deal. If you're doing 800 components in 5 hours and then they're all valves or pumps or compressors, I'd be pretty impressed and probably flag that myself to do. EPA's general threshold is going to be about 200 an hour or 500 in a day, in an 8-hour day. Very often you can see more than 500 in an 8-hour day or even a 10-hour day, something like that. So we do take it in consideration, especially if they're doing connectors and other types of components. If it's just valves, you kind of defer back to the time between monitoring events and look at, is that even possible? And that's not really a great gauge because you could have some that are just extremely insulated or some that have welded bonnets, things like you're not going to see unless you're in the field, and the database isn't going to capture it. So you could flag it as too quick, you go on the field, say, okay, I could get to that component in time, I can do the inspection, see if it passes the red face test. Inventory issues, pretty common. Failure to calculate leak percentage. I don't even want to go there. So, preventing. Who doesn't have a CD? I think I had one hand in here. I got one hand. So you can, 2 hands. There's just 3 hands. Do you count as 1 or 2 over here? Okay, 3 hands. The first thing I would do is, 1, make sure my monitoring is good. If your monitoring's good, you're going to get a lot less flags. Second is inventory. Check those 2 things very first. Things like open-ended lines, if you walk out there and you have a big problem, that's an operation issue that you need to get control of, and the site needs to get control of, which is probably going to be above your pay grade because you're dealing with other groups at that point. I don't know if it's necessarily doing this voluntarily. I think just the way our engineering in general is going, we're going to this lowly technology without even the environmental's knowledge because it's better design, it's better reliability. And if you're an engineer, those are what you want. So for some sites, you may already have a lot of low E and not even know about it. But you can talk to your engineering folks about that. I would not accept their first draft of language. You should have enough passion within your program and understanding that you're doing a good job to fight for it. Going in there and blanketly saying, yeah, we accept all these, is going to put you in a world of hurt real quick. Know what impacts each line of the consent decree are going to have. A really nice example of this, and this is after it got signed, a site, almost every consent decree I've read, at the very beginning says that fugitive components and light liquid gas vapor service are covered underneath the consent decree. This one did not say that. This one also had that every component had to be tagged later. So not only did they just generically throw in all the fugitive equipment covered, they now had to go tag all their heavy liquids because they didn't pay attention to these little nuances within the rule or within the consent decree. Know the provisions that you can negotiate to which ones you can't. This day and age, don't fight low E, you're going to get it. You're going to get an audit. You can say how much. DOR limits, probably going to get one. But again, look at your history. Say I've not really gone over this cap, maybe reduce a little bit and say I think this is acceptable. We've not abused the DOR system. Anything you kind of give them, just it's going to be a give and take. If you go in there stonewalling, it's not going to be a pleasant negotiation, which you can call it a negotiation if you want. ELPs are really the EPA's most effective tool of controlling fugitive programs. Writing a rule, as you can tell from the refinery sector rule and the uniform standards, it's not an easy process, and there's a lot of people that are going to fight back for it. When you get down to the consent decree level, it's just the site and EPA. API, other advocacy groups don't really get involved at all. They're always going to be evolving, so you do need to kind of pay attention, kind of the history of languages, maybe talk with other people, other networks to see what definitions worked well at facilities, what definitions included a bunch of stuff that you never wanted it to. If you're not a refinery and you've been getting some attention, I'd probably think that you might want to start focusing on keeping things up to date and having good records, keeping your site clean for if they do visit. But likely it's just going to be a database request, so really start combing through the records, making sure everything matches up with your reports. All right, what do we got next? I think y'all are going to get out early. Who's sad about that? No one.
We still got some LDAR 101 to finish at the end.
Well, you got that. I'm
Not
out.
everybody has to-
I'll leave for that one.
It's optional.
All right. How many people have terminated consent decrees that are still running? Let's rephrase that. As refineries. Do what? You're getting ready to? All right, so we're just going to let him teach because we really just speculate here. It's a risk you take.
That's the feedback we get.
How's your audits?
Because they're going to come back and put you under our work.
You know, I think, frankly, if you get in the...
Careful what you ask for. Most people have not been able to get out of a second. So, you know, why change what you got?
Yeah, the big caveat that's going to come up with the termination, and you'll see it, the big discussion on what it is and what it means is substantial compliance. Well, if you look at the numbers, if I give you an open-ended line and I looked at 1,000 and you had 1, those are pretty good numbers that you're in compliance on a sum total basis. But really defining what that is for EPA, and I think Coastal last year said, submit it and we'll see. It doesn't really give you much comfort that what you present and what you think is substantial material compliance is really going to be substantial material compliance. You know, if you're already in those processes, any insight would be pretty valuable.
We have not begun the process, but the term of our procedure just expired.
Mm-hmm.
And we've not completed all the requirements. Fortunately, it's nothing with a specific deadline that needs to be done. The state just has to reissue and apply for it.
Right.
So once we get to that point, our council does want to terminate the procedure.
Yeah, I would say a big pursuit of that too is if a lot of the permit conditions that you're adding already cover that, there's really no sense for the consent decree because you'll be under the permit. So that may be another option if you're already in the permit renewal processes and you think there's some things that are really helping your program out and maintaining compliance. If you wanted to include those in your permit, that's completely fine. You can put what you want to put in there. That's above and beyond just the simple regulation. You know, as we get into stuff like the refinery sector rule or uniform standards, a lot of the things that you see in the early consent decrees or the second round consent decrees made it in there. Low leak was one of those requirements. Low leak technology, monitoring of open-ended lines, things that are now in people's individual consent decrees. So at some point, what are we going to cover with the consent decree other than a lower leak definition? Termination language varies, but it generally follows the pretty same standard. We'll talk about these. There's a couple other variations. Believe that they're in compliance with the requirements of the consent decree, and then it shall certify the U.S. and the plaintiff interviewer. BP may seek termination by certifying that to the United States that the site has demonstrated substantial compliance with the programs. You know, that's the big caveat, like, what is substantial? I would argue to say, like, if you have not seen a substantial reduction from the findings you initially had, not substantial. So if you got approached with a consent decree for having 1,000 overlooked components, now on average when you get your audits that you're mandated, there's maybe like 3. I would say that's pretty substantial improvement on my my overlook control. Open-ended lines, I mean, that's tough. You could have a turnaround and somebody can come in right afterwards and go look at stuff that was been worked on heavily. If you're a normal operation, you expect none without some sort of authorization under maintenance or something like that. So that one would be harder to do, that kind of comparing apples to apples based on what you went in with the consent decree. Things like mismonitoring, you could easily quantify those and compare them to the baseline you initially had. I think we covered that one. like we said, number of compliance events. One of the things that we try to do in like benchmarking, we like to have a point of reference. So if I tell you you have 20 open lines, is that bad? I think it's bad, just having that many, because if you look at the stipulated penalties for opening lines, it's not cheap. Get very expensive. Now, if you have 20 overlooked components, really understanding what that's for, if they're kind of onesie twosies here and there, you know, that's one thing. If you're missing an entire process, that's something completely different. That's, you know, not doing your applicabilities right. Onesie twosies could be operations doing a midnight installation. But if you put that comparison with how much you're doing the inspections, that can be quite revealing. And very often, at least from the records basis, we don't find a lot, or rephrase that, we don't find, for the most part, facilities having a lot of stuff on the database end to report as kind of deviations or non-compliance. A lot of the databases have gotten pretty up to date. There, again, some snafus here and there. You know, some glitch happens when you're starting to add 6 regulations in one rule or in one database, or you try to do a super rule, which takes the most conservative of all of them, and it gets a little messed up on the implementation of that rule. But again, those, we don't see too many of those anymore. Again, really everything comes down to, I think, for the substantial material compliance, that you're documenting at some point some baseline versus what the actual impact is. And you do it on a pretty regular basis, whether you know it or not. So when you're going in, you're reporting, somebody's reporting open-ended lines, you should know how many open-ended lines you have. And if you don't know how many you have, it's not that hard to guess. We assume about a 20% open-ended lines to valve, total valve population. If you look at a control loop, there's, you know, anywhere from 5 valves on there with 2 bleeders. You got your random bleeders, mainly used for pressure testing, things like that, that are high points, low points. They're every now and again, but 20% seems pretty conservative if you just need a ballpark. Sample systems should be very easily to identify and inventory. You're not going to have a whole ton of them. You'll probably have 3 or 4 ones kind of per process. So if you've got a bunch of liquids, you may have a sample on those. If you've got really big processes, you could probably have up to 20. But benchmarking those against yourself and taking the data you already have within your database to figure those out. Also, your historical reporting, deviation reporting could be valuable. You have the monitoring and all that data in your database. You can take your historical records and actually look at trends. Let's see. Yeah, most of it's going to be a record keeping review. One is budget. They're not really going to come out there to your site, so it's easy for them to request a backup file. If they do come out, they're going to be doing comparative monitoring. They will do field walkdowns. I would say if EPA is on your site, you have a technician immediately follow and monitor every single component they have and document that reading. You know, they're people too, and they can make mistakes. So if something comes up and you're not in agreement, that's something that, I mean, you could work it out amicably. But if you don't have somebody do it, then you really don't have any way to say, well, they didn't do it right, or our data's better, whatever. It also is more defensible if they're claiming not doing method 21 properly. Electronic data mining, we'll talk a lot about that. Basically, the new requirements within the consent decree cover everything. Basically, looking at, so if you have a new consent decree and you have low leak, they're going to take that date, they're going to cross-reference that with when it was installed. They're going to look for the documentation for that specific component. If you don't have that component type in there, they're going to ask for you to go tell them what that component type is and give them the documentation. So if you're already installing them, put the manufacturer, maybe a link to whatever the document is. Most databases can handle it. You're going to do the calibrations. You're going to do the initial inspections. You're going to have all the repairs, the readings for those, delay repair documentation. Pretty much everything that's in the record keeping requirements they're going to want. termination planning. No, I think we're still on this one. I would say probably if you're getting close, I would do some sort of kind of routine field check to verify that your open end line component identification is still good. In case they do decide to come out and visit and validate that you are in substantial compliance. From being an auditor myself and just human nature, if we're asking to look at something and it takes you 2 days to get it to me, don't really have a warm and fuzzy. That's immediately going to throw some flags, but if I ask you for some DOR forms, there's no reason why you shouldn't have that in a filing cabinet, nice and neat. Same with calibration records. That stuff should just be stored away properly to begin with, not have to fish for it. I will say this gets semi-complicated, and if you're preparing for an inspection or something, have operation inspections. So if they're doing your pumps, have that record, have their records of those pump inspections. Anybody not in your group, go ahead and have their records if it is part of the record-keeping requirement handy. Anybody have any other best practices? Color P&IDs. The consent decrees do have a pretty substantial cost of implementation in there, especially if there's what they find a lot of non-compliance. A lot of it's going to be on the record keeping side, a lot of it also on the process side these days, because again, we went from find leak, fix leak, to just prevent leak. Well, in order to prevent leaks, you have to have a very complex process to do that. So having that hierarchy of just the process of going all the way from procurement, the engineering design, the entire process takes a lot more work on the front end. And that's kind of the stuff they want to see too. So if you've already integrated a lot of your procurement and talking about design engineering stuff, that could be things that you can say you're doing to substantially comply ongoing. Because yeah, you may statically be saying it's in substantial compliance, but they also may want to look forward, like what system do you have in place to verify that you are indeed going to stay this way. All right.